Boost.build is a complex tool that helps you create fully functional applications that rely on Boost using your compiler, such as GCC. It provides an automated command line approach to performing tasks that using Boost.build. Boost.build is a complex tool that helps you create fully functional applications that rely on Boost using your compiler, such as GCC. It provides an automated command line approach to performing tasks that some developers prefer, especially working repetitive tasks where the I simply gets in the way. You have already used Boost.build several times in this chapter to build the Boost libraries, a specific version of Boost.build for compiler, as well as the Boost tools. The following sections provide some helpful hints and tips for working with Boost.build. Getting a successful build. Every time you use the B2 command, hi Baron Prakash and Harry. I was just thinking about you, my earlier stream. Also, hi Dylan, thanks for being back. Also, Baron Prakash and Harry, thank you for the like. And Dylan, if you like too, thank you. Oh. Okay, the following section provides some helpful hints and tips for working with Boost.build. Getting a successful build. Every time you use Puran Precautionary said don't forget to sub and like, guys, this channel live stream with respectful. Thank you. And Puran Precautionary said hi. Hi. Getting a successful build. Every time you use the B2 command at the command prompt or terminal window, you use Boost.build. A few rules to remember when using Boost.build are to ensure that you have a path set up to your compiler, to ensure that you have a path set up to Boost.build, specify the toolset property to ensure Boost.build uses the correct compiler options. Use the --s prefix option to place the output in a specific directory. Oh, yo. I'm so bad with names. I'm so forgetful. But I do see her here again. Hello. Thanks for saying hi. And Paramount Precautionary welcomes everyone. Thank you. Remember, if you know these rules, you'll avoid the problems that plague many developers who are new to Boost.build. The bbv2.html file contained in the... This is when we show things. Hopefully my phone was charging. Code blocks, boost _1 _5 5 0 doc HTML directory contains the documentation for Boost.build. This is where you find a complete list of the Boost.build properties and options. In addition, the documentation tells you how to perform various build types, such as applications and libraries. Using the examples. Reading the Boost.build documentation will tell you a lot about the product, but working through the examples will give you hands-on experience. The Boost.build share Boost-build example directory contains a number of examples you can work with to build your knowledge of Boost.build. The hello example found in the hello subdirectory is the best place to start. Try this example out using the following steps. Open a command prompt or terminal window using the technique appropriate for your platform. 2. Change directories to the Boost.build share Boost-build Example, hello directory on your system. 3 optional, create a path to the code blocks compiler directory. 4 optional, create a path to the boost.build directory. 5 type b2 toolset equals gcc release and press enter. You see the following information presented at the command prompt, telling you that boost.build has created a release version of the hello example using the GCC compiler. That's what it looks like. Turn the page. 6 type cd bed /gcc dash mingw dash 4.7.1 / release and press enter. You are taken to the output directory for the hello example. When working with boost.build to create an application, the application hierarchy starts with the bin directory, followed by a compiler specific directory, followed by the kind of output such as debugger release. 7. Type hello and press enter. You see hello as the application output. The other examples provided with boost.build work approximately the same way. You open the command prompt or terminal window, create the appropriate environment, build the example, and then test it. Some examples require a special setup. You can find details of the setup requirements in the readme.txt file for each example. Using regression. Regression is an add-on for boost.build that lets you perform regression testing as part of the build process. Regression testing ensures that your application meets specific requirements and that changes you make to your application don't add potential bugs. Large organizations usually employ regression testing as part of major application projects because the testing environment becomes so complex you never need a product of this sort for smaller applications or for discovering new C++ features. As with boost.build, you get regression when you install Boost according to the instructions found in the obtaining and installing Boost for the code : blocks section of the chapter. Regression is an advanced tool that requires that you know a little something about Python as well as C++. Because regression is such a complex tool, incomplete, and currently in beta, it's well outside the scope of this book to describe. However, you can find the requirements and step-by-step instructions for using regression at, again, this is the 3rd edition of the book. The 4th edition is probably a lot less new. The current one I know of is the 4th edition. Anyway, http :/beta.boost.org /development /regression_tests.html. The regression add-on provides a number of specific capabilities that you may want to know about. The main regression website at http :/www.boost.org /doc /libs /1_55_0 /tools /regression /doc /index.html provides access to this information. If you do decide to try regression, make sure you obtain the correct version of Python and perform all required step testing using inspect. I was hoping to finish, but I just realized I'm still 10 pages away. 10 pages away. I'm starting to feel it. The sitting is getting to me, as it typically does. So, do I want to try and finish the 10 pages? Not particularly. Okay. Sitting is getting to me. Using inspect. Many organizations want to make changes to the Boost library to ensure that the library meets their needs, or to augment the Boost library to meet the new requirement. Whenever you change something, there is a chance that the change will cause compatibility issues because it doesn't meet the Boost library guidelines. In addition, it's possible for a developer to introduce errors into the Boost library that others will find difficult to fix. The inspect utility makes it possible for you to scan for potential Boost library errors after you make a change to it. Start inspect from the directory that you want to check. To make this process more efficient, make sure you set a path to the copy of inspect that you built in the creating the Boost Tools section of the chapter using the method appropriate for your platform. For example, when working with Windows, you type path equals C code blocks boost _1 _55 _0 dist then path and press enter. So a lot of things I left out seeing, that's why I was showing it. Inspect looks for errors in the current directory and all subdirectories. You can try it out by checking the library files you built earlier in the building boost /lib directory. Normally, inspect performs a complete check of the libraries. However, you can modify inspect behavior using the following command line switches to perform specific tests. License. Oh, really? That's good to know. Copyright. Really? That's very handy. CRLF. End. Link. Path _name. Tab. ASCII. Apple _macro. Assert _macro. Deprecated _macro. Min-max. Unnamed. Tip. Oh, that is really handy for what I'm trying to do. For my YouTube stuff I'm trying to make. Tip. You can use, YouTube media kind of. Tip. You can use any number of these command line switches. If you forget to the inspect command line switches, type inspect -help. Well, inspect space -help. And press enter. Inspect shows you a list of command line switches you can use for testing. Inspect also provides a number of command line switches that affect how it performs tests. The following list describes these command line switches. CBS performs a check of only the CBS directory and ignores all their files. Text outputs the results in a pure text format. The option is especially useful when you want to save the results to a text file for later analysis. Otherwise, inspect formats the output as HTML. Figure 4-7 shows a typical report. Click on this link to see details about a particular test and as the license status of each file within a particular directory. Okay, so figure 4.7, 47, inspect normally outputs its report as HTML. So that's your boost inspection report. This is HTML. Here's what you see on the web pages. Tip, inspect outputs information to the, inspect outputs information to the default output device, which is normally the console, your display. See, HTML in text form on a display isn't particularly helpful. Oh, I think that pizza's coming up on me. I have way too much stuff I shouldn't have eaten. And I get acid reflux kind of bad. Ooh. Excuse me. Most platforms offer some type of redirection feature so you can see the output to a file. For example, on a Windows system, you can type inspect myreport.html and press enter to output the results to a file named myreport.html. Brief. Reduce the amount of output text to the memory required to indicate success or failure of the various tests. Remember, inspect is sensitive about the ordering of command line switches. You must place the -cps, -text, or -brief command line switch first, and then the test switches. Otherwise, inspect displays an error message. Okay. The website at https://www.boost.org/libs/libs/1/055_0/inspect/index.html tells you more about working with inspect. Okay. On that note, this is going to do it for today's reading from C On For Dummies, 3rd edition, written by John Paul Mueller and Jeff Cogswell. I'm going to put 5 minutes on the clock to close out the chat. 5 minutes in 5, 4, 3, 2, 1, starting now. Anybody would like to put something in the chat, you're welcome to before I close out the stream. This is a great time. Oh boy, everything is just rough. All right. I'm waiting nicely. Would you like to put something in the chat? You got a little under 4 minutes before I close out the stream. I do not like acid reflux. That stuff is annoying. Wow, it's 7:47. I mean, it's not yet, but it's about to be. Point is, it's close to 8. Wow. All right then. In case anyone wants to put anything in chat, there's just under 3 minutes left. All right. Oh, that's better. All right. Just under 2 minutes left to put in the chat before I close out the stream. Oh, that's a thought. That might help a bit. Okay, I got an idea, something that could help with my current issue I'm dealing with. Hopefully it does. Either way, something to try. Less than a minute, but something to chat before I close on the stream. Nine, 8, 7, 6, 5, 4, 3, 2, 1. Happy New Year. Okay, out of time. Gotta close out the stream. Thank you, Nightbot. Thank you for your Prakash Harry. Thank you, friend who I don't remember your name, but I do appreciate you being here. Thank you, Dylan, for coming back. At least for a bit. Thank you to anyone who I may have missed. And thank you to anyone who might check this in the future. Stranger things have happened. And whenever, wherever, however, whatever, just make the most of it. That's the most important part. Bye-bye.